Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at how do we explore for petroleum resources. So when it comes to looking for petroleum, you can really split it into two periods. There's the pre-World War II period and there's the post-World War II period. So pre-World War II, the vast majority of oil discoveries were made in areas where there were already natural seeps at the surface. So geologists could go around, they could see there was oil coming out of the ground, and so they knew there was an oil forming layer somewhere in the sequence of rocks. So these early geologists would then go around, they would try and identify where this source rock was. So they would look for rocks that had a distinctive medium to dark brown black color. And of course, this would be a strong indicator of the presence of kerogen, which is of course the starting material for forming oil. And depending on the strength of that brown color, you could also use it to crudely imply the kinds of temperatures that the rock had managed to meet. So had it reached the sufficiently high temperatures for that kerogen to actually transform into crude oil. They would also go around and they would try and find source rocks, and then they would also smell them, and they would be looking for that petroleum smell, which would be another strong indicator that the kerogen within those layers had been breaking down to produce crude oil. So once you actually manage to locate your source rock, you're then obviously going to be hunting for possible reservoir rocks. You're going to be looking for rocks that can act as seals. And then, of course, you're going to be looking for structures, which are going to allow the oil to become trapped. So early pre-Second World War geologists are going to be focusing on the stratigraphy of an area. So the layers of rock, they're going to be looking for that source rock, the reservoir rock, the seal, and then they're also going to be looking for structures. And geologists are going to be going around, they're going to be mapping how the layers of rock are dipping, and they're going to be modeling how those layers of rock are going into the subsurface. And so by using that kind of information, they're going to be able to identify areas where you have all the requirements together, where you have the source rock, the reservoir rock, the seal, and the structure that's going to allow you to form the trap for the oil. Now, after the Second World War, we begin to see an increase in the use of seismic reflection studies in order to try and identify features of rock which are likely to host and produce oil. So in terms of seismic reflection studies, they actually first began all the way back in the 1920s. And there is some dispute about where the first successful ones took place. Some people say Texas, some people say Oklahoma. But we know that from the mid-1920s onwards, we had very, very crude seismic surveys taking place, which were accurate enough to allow bodies of oil to be identified in the subsurface. Now, seismic reflection began to become even more common after the end of the Second World War as technology began to increase. And once you make it into the 1980s, where the power of computers begins to steadily increase, it allows a lot of seismic data to be analyzed relatively quickly and in relatively high detail. So all of a sudden, from the 1980s onwards especially, you begin to see the collection of seismic data and the analysis of that seismic data becoming more and more robust. Now, the question becomes, why move to this method of seismic data collection in order to identify where oil is located in the subsurface? Well, the simple answer is the vast majority of the near-surface oil reserves had already been exploited. And so this means that if you want to find new oil reserves, you've got to start looking into areas that you previously couldn't analyze and image. And so this means you have to move into environments that are more challenging, like the oceans, or you have to move into environments that you can't see from the surface. So we're looking at deeper and deeper in the rock strata of an area. So modern geologists are going to use seismic surveys, and these seismic surveys are going to look at very large packages of rock, and you can actually see a seismic survey right here. And now, seismic surveys aren't so accurate that you can pick out individual layers of rock, but certain layers of rock, especially when there's a significant change in the physical properties going from one layer to another, or if you have a layer of rock that's particularly thick and quite wide, it will begin to show up on these seismic surveys. And so you can use these layers of rock essentially to say, right, here's the layer of rock here. We can see it's coming up here, coming up there, coming across there. So you can use these very obvious layers of rock in your seismic survey to see what's going on in the subsurface. And if, of course, that layer of rock happens to be a reservoir rock, well, then you will be looking for structures that may act as a trap. So you'll be looking at faults, you'll be looking at folds maybe, or possibly even unconformity. And so by using these seismic surveys, it allows geophysicists to analyze the subsurface and then pass that information on to geologists. Geologists will, of course, come in and they will identify their preferred targets, at which point they will start drilling boreholes. And as they drill down into the earth, they will obviously be collecting the rocks that they are drilling through, and they'll be using that to analyze the stratigraphy of the area. So they'll be looking at, right, what are the environments in which these rocks are forming? So the geologists, when they're looking at these rocks, will first of all be looking to see, are these rocks the correct age? So they'll be looking for certain fossils within the sequence of rocks that's going to say, right, this package of rocks formed during this portion of geologic time. Now, there is a reason for that, because certain periods of geologic time are more productive for oil versus other periods. So if you can find a rock that is the correct age, that's a really good starting point. So if you find a rock, a package of rocks that formed during one of those periods where you had a much larger number of oil deposits being formed, that would suggest, right, we are already looking at something that could possibly, produce oil for us. Obviously, we're then going to be looking for rocks that form in the correct environment. So we're going to be looking for that all-important sequence of rocks, which gives us indicators that there is a high amount of carbon in the form, which was added as organic material, and that carbon was entering an oxygen-poor environment. So they're really going to be looking for those very carbon-rich layers of rock within the sequence, and that's also going to be showing the geologist that, right, this is a sequence of rocks, and during some portions of the formation of this sequence of rocks, conditions were clearly right to allow us to form decent source rocks. And of course, they're also going to be looking at the sequence of rocks, and they're going to say, right, are there any rocks in this sequence that would make good reservoir rocks? And are there rocks above those reservoir rocks which are going to act as good seals? They're also going to be looking to see if the rocks have been heated to the correct level. So over the years, geologists have become more and more adept at being able to look at layers of rock and analyzing the fossils within them, and especially the color of those layers of rock. They've been able to come up with methods that allow them to relatively accurately estimate the temperature to which the rock has been exposed. So they can use things like the color of the rock. They can use things like the presence of certain minerals in the rock. And they can use that to essentially say, right, this rock looks like it's reached a temperature somewhere in the oil window, and so it's reached a sufficient temperature for that kerogen to begin converting into crude oil. And of course, as previously mentioned, when they're looking at the rocks in that sequence from all this borehole data, they're going to be looking for suitable reservoir rocks, suitable structures to act as traps for the oil in those reservoir rocks. And so that's where these seismic surveys really become very, very important to modern geologists looking for petroleum, because they allow a window into the subsurface, sometimes going down kilometers into the earth. These are layers of rock that we would, under normal circumstances, never be able to see. So we would never know that the sequence of rocks required to form oil was present in those areas. But by using seismic data and drilling boreholes, we can essentially take a section, a stratigraphic column, all the way through this sequence of rocks, and that can then be used to say, right, these are good source rocks, these are good reservoir rocks, these are good seals. We're going to look at the seismic section. We're going to try and work out where those layers of rock are on this seismic section, and then we're also going to see, are these rocks deformed anywhere to form a structure that would allow the oil to become trapped. So geologists, as mentioned, will map rocks at the surface to understand the geology and may drill boreholes to analyze deeper sequences. This part is more pre-Second World War, so geologists mapping the rocks at the surface, whereas the boreholes are more post-Second World War exploration. And in terms of geophysics, to produce these seismic sections, they're going to allow geologists to image the subsurface, and they're going to allow the position of key beds to be noted. They're also going to, most importantly, allow the identification of traps. So they're going to be looking for folds, they're going to be looking for faults, they're going to be looking for salt domes and unconformity. So there's lots of information that can be produced from a mixture of both borehole data and seismic data, and that's going to allow geologists to say, right, this is a likely area to find oil, and they're going to drill. Now, a key point to remember is that there's no certainty that even if they identify the perfect set of conditions, there's absolutely no certainty that they are actually going to intersect some kind of oil body underground. And so, the risks involved in this kind of exploration are very, very high because, we are talking about tens to hundreds of millions of dollars being risked on, depending on the conditions, on a single borehole to see will it intersect oil. And so this is why the vast majority of oil exploration has to be undertaken by absolutely massive companies that have the kind of money that allows them to do this kind of exploration. All right. Thank you for watching, everybody.